Hello, my name is Jena Huntington, and I am a hydrologist with the USGS Nevada Water Science Center. And my presentation is about an early warning pesticide monitoring program in surface waters of Nevada that we did in cooperation with the Nevada Department of Agriculture, and I'll refer to them as NDA. So I'd like to give a shout out to my cooperator and co-author, Derek Entz from NDA. Pesticides, what are they? Well, a pesticide is a substance or a mixture of substances that are used to kill or control weeds, plant diseases, insects, or other pest organisms. Every year, about 1.1 billion pounds of pesticides are applied to agricultural land, non-cropland, and urban areas across the United States. Of course, these are used for a beneficial use, but there is the potential for contaminating our water resources. So here's a diagram that shows some of the possible ways that pesticides could get into our water. And they can be broken into two groups, the first of which is a point source. So this is when a pesticide contaminates the water directly at one place. So that's at a spill site, at a disposal site, or even pesticide drift during an application. But by far, the most common way for pesticides to enter the water is through a non-point source. And these include agricultural and urban runoff, erosion, leaching from application sites, and even precipitation that's been contaminated by upwind applications. One thing listed here that you might not know is chemigation. That's a process when pesticides are applied to the land through irrigation systems. A little bit of background on this project. The EPA has a voluntary monitoring program in each state for monitoring pesticides in order to protect the groundwater and surface water. And then that information is used to educate applicators, farmers, and the public about ways to prevent loading of pesticides to the water resources. So this is a program that we have been helping NDA with for a number of years. A previous phase of the study dealt with strictly groundwater, but we will just be talking about the surface water portion of the project now. NDA needed an early warning system of flawed application practices. This could be that too much of a pesticide was being applied at a given time, or that they were being applied under the wrong conditions so that it promoted excess drift or more runoff than would be normal. But we wanted to know early on if pesticides were getting into the water resources. So what we wanted to do was start earlier in the year when applications were just beginning so that the data could come back and be used as an educational tool for the pesticide applicators. So the plan was to design and implement a pesticide monitoring program that would quite simply determine if a pesticide or their degradation products were present in surface waters across the state. So here's just a little map showing the sites that we sampled, and we will be going into more detail in that in just a second. The type of sampling we did for this project was different than a typical water quality project because a normal sample, called a discrete sample, is when it's collected at a particular place and time and gives you a snapshot of the water quality right then and there. But that doesn't work for pesticides very well because they vary so much temporally and spatially, and that has a lot to do with how pesticides are applied and runoff and stream flow. So if we were to take just one sample, that the concentrations would likely be well below analytical reporting limits. So what we needed was a longer sample, an accumulation of pesticides over a larger period of time. So that's why we decided to go with passive monitoring. And what we did was we chose to use the POCIS, which stands for Polar Organic Chemical Integrative Sampler. And what they do is just trap polar organic compounds, in this case pesticides, and accumulate them over time, which is generally 30 days, until the concentrations are high enough to be detected using your standard laboratory analyses. So this is what they look like. They are basically look like a round white plate filter, and because concentrations are so low, they are deployed in triplicate. So you'll see here that each one of the POCIS filters are mounted in a metal bracket and then inserted into a metal cylindrical deployment canister that has holes all through it. It kind of looks like a cheese grater, and that's what's deployed and allows the stream flow to move through the deployment canister through the 30 days that they're out there. Here's a few pictures from when we were deploying our POCIS. Once you get your bracket mounted inside your deployment canister, you need to figure out a way to weight it down so that it's not moving once you put it out in the stream bed, but you also want it raised up off the bottom of the stream bed so it doesn't get completely covered in sediment or mud and muck down there. So one way we found was to wire them to cinder blocks and allow the cinder blocks would allow them to be up off the bottom, but also secure them there. Depending on how the flow was, we sometimes used 2 cinder blocks, and that seemed to work pretty well. Another thing we did was to pound a fence post into the stream bed and then kind of ringer the cinder block over the top of that, and that is like kind of a secondary safety net to help make sure that it stays in place. So on the left-hand side, that's Derek Entz, my cooperator and partner, and on the middle and the right side, that is his predecessor, Brett Allen. And then after a month goes by, you go back out to retrieve your POCIS. Sometimes the conditions can look a lot different because we typically deploy these in the springtime when the flows were high, but that's also when farmers are applying the pesticides, so you're more likely to be seeing the pesticides in the streams during that time. The canisters can come out of the water looking pretty muddy and mucky, but that's the whole point, is that cheese grater type thing keeps all of the big debris out and keeps our POCIS pretty clean. And surprisingly, when you open that up, everything is pretty secure and tight and not too bad on the inside. So our POCIS sampling history was 5 years of data collection between 2012 and 2019. During that time, we sampled 26 sites in 4 different hydrographic basins. Each year, we focused on one watershed, and there are typically about 5 to 6 sites within the same watershed. The sites were chosen to be down gradient from agricultural or urban areas and also adjacent to existing USGS stream gauges. And that was because once these things are deployed, you want to make sure you keep an eye on the water level so that they do not become exposed to air. We're trying to sample the pesticides in the water, not anything that's airborne. So we did that, and they were left out there for approximately 30 days and then retrieved and analyzed for nearly 80 different pesticides by the NDA laboratory in Sparks. So any concentrations we got, they were assumed to be pesticides from upstream sources, so as they came downstream. Just to recap, in 2012, we sampled 4 sites on the Walker and 2 on the Truckee. 2014, we did 6 stillwater agricultural ditches in the Fallon area. 2015, we had 6 sites on the Humboldt River. 2018, we had 5 sites on the Carson River. And then in 2019, we had 6 sites on the Walker. 2 of the 6 sites were replicates of the sites that we sampled in 2012. Now we'll talk about the data. Of all the pesticides that the POCIS were analyzed for, there are a few that are of particular concern to NDA, and that's because of their widespread use or their chemical characteristics that make them vulnerable to leaching into the surface water. And once they're into the surface water, then there's the potential for their concentrations to either approach or exceed human health or environmental reference levels. So NDA monitors these pesticides in coordination with the EPA, and that's so that they can understand the annual pesticide usage, pesticide incidence, and of course the potential for contamination of the water resources. So the way that a pesticide can land itself on this list that they call pesticides of concern is by either the frequency of detections, an upward trend in the frequency of detections, widespread detections across multiple counties, or if the highest concentration is above 10% of its health and environmental threshold level. So once it's on there, each of these are reevaluated once every 5 years, and they can be removed from the list if there are continued decreases in the number and severity of the detections. So there are 7 pesticides on NDA's pesticides of concern list, and I broke them out here into 2 groups, into herbicides and insecticides. And you'll notice 2 of them are color coded a little differently in a red color. That's atrazine and oxymol. And that's because they are special use permit required pesticides, which means that you have to have a special permit to apply these, where all the other ones are general use and the general public can apply these without any kind of permit. So let's look at some results. This is a bar chart showing the number of detections of each of the 7 pesticides of concern, broken out by herbicides on the left and insecticides on the right. And it's pretty simple to see that the herbicides were the most detected form of pesticide, and 2,4-D was the most often detected. It was actually at 88% of the sites. Both diuron and 2,4-D were found in every watershed except for the Truckee River. And curiously, diuron was found in all the Walker River sites in 2012, but not at all at any of the sites in 2019. So I guess it's not used in the basin anymore. Hexazone was found in all the rivers except the Truckee and the Humboldt rivers. And atrazine and bromacil were obviously detected less frequently, but they were the only pesticides found in the Truckee River. Oxymol, which is a fairly new member of the pesticides of concern list, it was only found in the Walker River in 2019 and only in the main stem of the river channels. So now let's look at concentrations. This is a summary chart showing our 7 pesticides of concern on the y-axis, and that white line is separating the herbicides from the insecticides. And we have concentration on the x-axis in micrograms per liter. And what we're showing is minimum concentrations in green bars and maximum in red bars. And the very first take-home point on this is that based on the x-axis, these are very low concentrations, all less than 0.1 microgram per liter. The minimums barely even show up on the bar chart. Bromacil is the most visible one there, and that is equivalent to 0.0001 microgram per liter, so very small. And our 2 largest concentrations, 2,4-D and bromacil, they're just bracketing the 0.06 microgram per liter concentration there. Both of these were found in agricultural drains in the Fallon area in 2014. Now I threw up the MCLs for 2,4-D, atrazine, and oxymol. These are the only ones that have EPA established MCLs, and I just want to point out how very low these concentrations are in comparison to the MCLs, like several orders of magnitude lower. To summarize our passive monitoring findings, based on the concentrations that we just presented, all pesticides that were detected were very low concentrations and several orders of magnitude below any established EPA MCLs. Of those that were detected, herbicides were the most frequently detected form of pesticide.
And because of these low concentrations, we really do feel that passive monitoring and the POCIS was the right tool for the job. It allowed us to have samples that were integrated over time and really fit this project well.
So now I want to talk a little bit about glyphosate. Glyphosate is a common and widely used herbicide for weed control. It's used both in residential areas and croplands. It is the main ingredient in the widely available product called Roundup, so that may be how you recognize it. The EPA has set a MCL of 700 micrograms per liter for glyphosate, and that's because of potential for kidney and reproductive damage. So because it's so widely used and it has some health effects, NDA decided they wanted to add that to our sampling. So in 2018 and 19, we sampled for glyphosate to help NDA understand glyphosate application practices by the local homeowners and farmers. So POCIS samples cannot be analyzed for glyphosate, so discrete samples were collected both during POCIS deployment and retrieval on the Carson River in 2018 and the Walker River in 2019. And those were analyzed by our USGS pesticide lab in Kansas. So what we found is that in 2018, glyphosate was detected in 3 Carson River sites, and the concentrations ranged from 0.02 to 2.9 micrograms per liter. And then in 2019, 3 sites on the Walker River had glyphosate and ranged from, again, 0.02 and up to just 0.1 micrograms per liter. So it was an interesting endeavor, but all the concentrations that we have seen so far in discrete samples was far below the 700 micrograms per liter MCL. So all the information that I've presented today is available and summarized in a USGS fact sheet that was just released a few weeks ago. The web address is listed here if you're interested in accessing it, and it has all the data in there. So that's all I have for you today. I'll be available for questions and answers during the live Q&A session right after the following presentation from 2:40 to 3 o'clock, and I hope to talk to you there. Thank you.